Hey, good day all. Can you guys hear me? Perfect. Hey, thanks for joining. I took the, why is my bar still down? I took the most sustainable option here. Not traveling to Australia from Europe. I live in the Netherlands. So I'm going to do this virtually for you guys, but thanks for participating. So Robert Leeuw, I work in EV charging since 2013 already. I'm currently technology evangelist at Pionix and ambassador for the Linux Foundation Energy. I have a background in protocol development. So for EV charging, I worked a lot on OSPP, OCPI. And early in my career at Ericsson, I worked on Bluetooth. How do you charge a car? There's a couple of different ways how to do that. Basic AC charging, what you typically do at home or on slow public chargers, uses an IEC protocol called 61851 mode 3. It typically uses an app or RFID for authenticating who the driver is and for payment. There's a more modern version of that called 15118, either -2 or -20. It isn't supported a lot. There's not a lot of vehicles that support this. And one of the things it can do is also bidirectional charging. So you can also discharge your vehicle at home to support the grid or use your car battery as a home battery. Then the fastest way of charging is using DC charging. There's a lot of different protocols for that. Early version was DIN. ISO 15118 is the new kid in town, at least for Europe and the US. And then Japan is on CHAdeMO. China uses GBT. So a lot of different standards out there for DC charging. These are typically seen on highways or also on parking places for supermarkets, for example, where you're just there for half an hour. You want to charge your vehicle. Nowadays, we also see them as smaller units for home and office. So then you do DC to DC, direct solar to charging, and you get DC microgrids. So you don't go from DC from your solar panels to AC, convert that back to DC for the charger for the vehicle itself. Upcoming also for this is bidirectional DC charging. The first vehicles are now being rolled out. Hyundai EV9 is capable of doing this. Yeah, what's involved if you want to charge a car? A lot of different companies, a lot of different protocols. Yeah, you need the EV manufacturer that makes a vehicle. You need a charging station manufacturer. These need to talk together to all the protocols that I already mentioned in the previous slide. Then there's a company that buys charging stations, installs them in the field, and maintains them. They are typically called charge point operator, CPO. Charging stations worldwide are nowadays maintained by OSPP. So there's one protocol. It's an industry standard for managing charging stations. There have been a lot of companies that had their own protocol before. Almost everybody at the moment now supports OSPP. Even Tesla is now starting to implement this on their latest charging station. At least that's the rumors that we're hearing. They're now selling their chargers also to other companies, and then those companies can still use OSPP to manage their Tesla charging stations. For the driver to be able to pay for charging, they need somebody that provides them with a contract. This is called a mobility service provider or an e-mobility service provider. Those are the companies that have contracts with the drivers, and then you can have an RFID card, an app, or a way of paying for this. They're very similar to what you typically use if you have a company car. You get a petrol card that you use for filling up your vehicle. With this, you get a card to charge your vehicle. And then all these mobility service providers have roaming contracts with all the different CPOs, which allows you to roam to different networks without having to have a charge card for every different charge point operator there. Now, all this is done via a protocol called OCPI. Now, having to set up, if you look at Europe, there's roughly 200, 300 CPOs, and there's probably 400 mobility service providers already. That becomes a technical nightmare, setting up all these different connections. So we have roaming hubs. There's a couple of companies in Europe that provide a central connection hub for different networks. So you can just connect to one network and have an access to a lot of different CPOs or MSPs, depending on which role you are in the market. US market is a bit different. There you have a lot more vertical integrated. There you have one company typically makes their own charging stations. They are operating themselves and they have their own cards, so there's not a lot of roaming. It starts to happen a bit now. I know in Australia roaming exists. I've worked for a couple of the networks already. Now, what we see a lot happening now also is payment service providers are stepping into the EV charging market. Early days payment was done by the RFID, and nowadays, if you have more and more private drivers starting to charge, everybody's so used to using their credit card or nowadays Android or Apple Pay to pay for filling up the vehicle. So they expect the same with EV charging. So nowadays you see more and more payment terminals on charging stations. There was a reason why that wasn't rolled out early days. Payment terminals are quite expensive. Installing a payment terminal on every AC charger was way too expensive. For a DC fast charger, that was affordable, but the payment terminals got cheaper. And now it becomes more and more affordable to have payment terminals with a couple of AC chargers as well. And then last but not least, yeah, we need an electricity grid. We need energy companies to provide the energy. So a lot of companies involved using a lot of different protocols to talk to each other. I almost forgot the grid operators also wants to influence the charging speed. All these charging stations take a lot of energy from the grid. The fastest chargers that are now available can do 400 kilowatts for one vehicle. Imagine having 10 of those on one side. That means they can do a couple of megawatts. Yeah, the grid operators want to have influence on that. If the grid is in trouble, they want to be able to decrease the amount of energy that these chargers take from the grid. Open ADR seems to be the most common one, but also IEC 61850 or SCP is used. So a lot of protocols to do this. And it's getting more and more over time. There's new versions coming out, there's new standards coming out. Depending on if this is public charging, we see a lot of work happening on home charging, home energy management systems, new standards coming out for home energy management systems. So more and more protocols, so it becomes harder to build anything that works with everything in the world. And this starts to cause problems. There's just too many variants. Early days when I joined EV charging for the first projects, yeah, there's a new EV coming out next year. Oh, the Tesla Model S is coming out. So we could prepare software we could test with the first Model S before it hit the market. Now there's a new EV coming out next week, and probably in a couple of years there's a new EV coming out next day. It's impossible to keep up with all these new vehicles if you're a charger manufacturer, and if you're a vehicle manufacturer, it's impossible to keep up with all the new charging stations and all the networks that are being rolled out worldwide. So it just becomes impossible to test. And then with all of these different standards, there are small variants in every implementation. They are just not reliable enough. Now, this can be solved. The simplest solution is to have one software stack in the middle. So if you have on the right a lot of different vehicles, if there's just one software stack running on all the charging stations worldwide, this becomes testable. So the OEMs can then test against one software stack, and all the operators and all the apps can test with one software stack, and then know this works. There are companies that have tried to do this as a commercial version, but that would create a monopoly, so nobody would trust this as a viable solution. And we really believe that this needs to be done open source. So the Linux Foundation Energy has Linux EVerest, an open source software stack for this, which is now being developed and being rolled out in the world. Our ultimate dream is to solve this even more. If you look at an open source world, within Linux Foundation, we also have Citrine OS, which is a backend for managing charging stations. This project started last year and is now as Linux Foundation Energy project since early this year. And there's 1.0 release was a month ago. So we see the same happening now on the backend management systems. Now on the car side, things are progressing a bit slower, but within Eclipse, there's the software-defined vehicle group, and they're working on trying to come up with open source solutions for the vehicle. So fingers crossed that in a couple of years, we are also starting to see open source implementation on the vehicle side. And then we get rid of all these different implementations and really solve the interop issues that we now see in the field. Yeah, open source has a lot of advantages for the current problems we see in the field. One of the biggest threats for EV charging is hackers. Imagine if you look on the picture that I saw a couple slides back. Let's go here. Especially the roaming hubs. If somebody gets access to a roaming hub, all these roaming hubs have connections to charge point operators, and those charge point operators have connections to charging stations. Imagine one hacker being able to control all the charges in Australia, turning them all off at the same time. This would cause such a big spike on the grid that would cause blackouts. So EV charging needs to be secure. So in the back end, but also in the charging stations, this needs to be secure. Now with proprietary software, yeah, it's closed source, so it's harder to hack something. But one of the advantages of open source is that security experts can inspect, validate the code, help fortify the code. And there's a lot of research that has happened over the years on the difference between, for example, Windows and Linux. Linux is way more reliable because it's that open that both the developers and the security experts can validate and keep in mind security, where with Windows, it's a black box. If something gets hacked, it's harder to hack it, but there's way more issues with it. Also, Linux Foundation Energy does a lot of security scans. So we try to do our best to make the open source software as secure as possible for EV charging. It needs to be more reliable. I already mentioned it a couple of times. It is not reliable enough. The worst numbers we've seen on any research was a research from in California, in the Bay Area. A university went around with a couple of students on all the DC chargers they could find and just tried to charge. And they ended up with 27% of the chargers not being able to charge a vehicle. That is not good enough. That is, if we start rolling out millions of chargers with this kind of reliability, that is going to be a big issue, and nobody will trust EV charging. So it needs to be improved. And this study is now 2 years ago. Things are improving, but a lot of this just comes down to there's way too many different implementations. A lot of it is connectivity, just plugging in the car into the vehicle, and they're not talking to each other. That is something we can solve. Open source is way more cost effective. When I started my career in '99, one of the first projects I did was do an implementation of TCP/IP for an embedded platform, because there were just two options. Either you build it yourself or you buy it. Now, this was a research project. There wasn't funding to buy a commercial TCP/IP stack. So we wrote a rudimentary IPv4 stack. Imagine trying to do that for IPv6, for anybody that's familiar with it. And now everybody's trying to do the same with EV charging. All those protocols like OSPP, 1511H, CDEMO, everybody's trying to write their own. Now let's try to make this a commodity. If we make this available open source, that means everybody will work with the same stack that is proven, reliable, and secure. And you don't need to maintain it. You don't need to develop it. And for a charger manufacturer, that will mean they can just focus on what's unique for their charger instead of having to implement a protocol that won't bring them any additional value in the market. Doing a good OSPP implementation won't sell you more chargers. Doing a really bad one will give you a bad name and won't sell chargers. But your unique features, your unique hardware, that's what should sell your chargers. Reliable hardware, that kind of stuff. Yeah, as I said, there are closed source examples available. There's a couple of commercial software stacks, but the biggest problem that you then see is it's harder to innovate on top of that. You can't extend the code. You can't make changes to it because you are working with a black box. You might have access to the source code, but you're not allowed to change it. And also, if you would rely on software and your supplier stops supporting it, and we've seen that in the field already once, is that the supplier said, "Yeah, we're not going to be maintaining this anymore. We're gonna step out of this business." And then there's chargers in the field relying on software that is not being maintained anymore. And on the long run, that's a security issue and that resulted in roughly 5,000 to 6,000 chargers that had to be replaced in the Benelux, so in the Netherlands and Belgium, because the software stack wasn't supported anymore. This is not what you want as a manufacturer. And also, if you buy in on a closed source software stack, you have to rely on that vendor. Now, with open source, you can rely on a vendor like Pionix. We provide support for a open source software stack. But if we don't do a good job, you can still go to somebody else to do the maintenance or do it yourself. So this was a bit on EV charging and on the advantages of open source. I want to talk a bit more on what is then EVerest. What's the project that we are working on? So EVerest is a Linux Foundation energy project. It was initiated by Pionix. I joined the company January last year. I think one of the best things my colleagues did is go to the Linux Foundation, say, "Hey guys, we have this idea for a project and we want to make this open source." And instead of what we've seen a lot of other companies do, and you guys probably have seen the same, yeah, we do open source, we put it on GitHub. But that doesn't make it a real open source project, because you want a project that builds a community where others are willing to contribute to a project. And just putting something on GitHub typically means nobody else will contribute to it because it's still seen as a project from that specific company. And by making this a Linux Foundation project, we really get other companies that start to contribute. It's a complete stack for EV chargers. We try to get all the protocols implemented that you need. It runs on embedded Linux. It's an Apache 2 license, so you can do whatever you want with it. No requirement to give back to the community. Yeah, we would love people to give back to the community with their experience, especially working in different regions, different requirements, different legislations. There's always new requirements coming in, so it's really nice if people from different countries give back to the community as well. This really helps improve the software stack. Our aim is to support as many different platforms as possible. Yeah, we need to run embedded Linux at the moment. We have on the roadmap, we want to run this on a microcontroller, but it's really built on top of Linux. So that will be a big step if we ever do that. And if you want, you can build your own. So EVerest itself is the software running on the hardware. So yeah, you will need hardware. On that, you can run EVerest. And if you do a commercial charger, you will need some unique functionality. You will need a display or some human-machine interface. That isn't part of EVerest. There is some demo code that we as Pionix have created, but that is not meant for production. And that should also be something that a charger manufacturer should do themselves. Now, we try to support as many use cases as possible. This can be a simple AC charger, just something, a wall box at home, up to a big DC charging site with multiple satellite chargers, including energy management between the chargers, load balancing. EVerest is able to support all of those different use cases. And also for all the different protocols out there, that's the goal. All of this is already working, all the different protocols. That's something we're actively working on. EVerest is a completely modular microservices architecture. We run MQTT on the charger, and then all the different modules have a what we call EVerest core wrapper, which wraps C++. So you need to provide some JSON file, and that compiles into MQTT interface, which makes all those modules modular, talking over MQTT. And you can easily add and remove modules. Even if you develop You can even change the configuration, restart Everest, and get different functionality. You don't even need to recompile. As long as you have all the modules on the system, you can just change the configuration to add and remove modules. For first step development, we have a graphical user interface that you can run on the charger or on your laptop to configure Everest. I will show a little bit later on that. We have energy management built in, and we support a lot of different languages. The core of Everest is C++ 17. Rust support has just been added. Quello, one of the companies that is actively contributing, is heavily focusing on Rust, and also one of the customers that we as Pionix work with is focusing on Rust. So we see more and more Rust in Everest. There is Python and JavaScript possible as well, but we don't really believe in doing that on a production system. If you do some research project, that's fine. But running Python or JavaScript on a production charger, it's not really the way that people typically go, because you don't want to compile. You want a compiled language and not a scripting language, because that requires a lot more resources on a platform. And if you're going to sell tens of thousands of chargers, you want to be running on the cheapest hardware you can find. So scripting languages aren't used a lot. Yeah, if you look at the repository of Everest, you see a lot of Python and JavaScript code. All of that is for the build pipeline or for testing, not for production code. The Everest community, as I said, we have a technical steering committee that's a requirement from the Linux Foundation. Really nice. They're responsible for the architecture and the data and all the and the roadmap of Everest. Yeah, it's us, Pionix. It's charged by the manufacturer of charge controllers. Quello, a CPO/charging station manufacturer, the one that is really pushing for Rust. Really nice guys. And then since early this year, the Joint Office of Energy and Transport in the US has also joined the project. They're responsible for NEVI funding. So the Biden administration made a couple of billion available for EV charging infrastructure. And the Joint Office is responsible for making sure that all the chargers comply to the requirements from NEVI. And they've selected Everest as the reference platform for the NEVI requirements. So they're making sure that Everest can comply with the requirements that are set by the government. So they're actively working on testing and adding features that are needed for the US market. So they gave us a lot of visibility in the US market. A lot of contributors already on the project, and it's really growing exponentially. It's really nice to see the difference between when I started in January and the moment and where we are now on the discussion that we are having within the community. So if you want to build a charger yourself, you could spin up our UI. So you need an EVSE manager. This is the core component. This is really what runs one charging connector. If you want to build a charger with multiple connectors, multiple of these EVSE managers, this contains all the charging logic, and it orchestrates everything that needs to happen within one connector. Now you need to run this on a hardware drive board. I will come back to the Yeti board a bit later, but this is the hardware board that we have as a development kit, and this is really the board support package that connects all the functionality to the specific board that Everest is running on. Now you need energy to manage a charging station. Even if you build a dumb charger, you need the energy manager. Yeah, you can configure it to just give all the energy that is available, but you need an energy manager. Typically, this is set to the maximum amount of power for the grid connection that is allowed to be taken, but it's also quite easy to make it a bit smarter by giving it certain inputs and certain profiles that it needs to follow. Now, to have authentication, so if you make this into a public charger and you want somebody to authorize, you need the out manager, and the out manager then needs a way to authorize. In this case, we selected RFID, so we use the RFID module, and then all these modules are linked up, and you can see every module. I forgot to tell that earlier. Every module has a couple of in and outputs, and if you have the UI open, you can hover over it and it will show you what that in or output is. And all of this is based on the JSON files that come with every module. So if you compile the modules, the UI will read all those files and gives you visibility on what you can connect to this. So you can hook up in and outputs depending on what this module has as in and outputs. And this is also how the UI works, but also compile time. It will check if all the modules are available that you need to build a charger. Because it's a microservice architecture, it's easy to make mistakes because you might not have certain modules that are required to make your charger work. Now, if you then want a charger that is manageable remote, you need OSPP. So you bring in the OSPP module. That also needs the system module, because the system module is responsible for firmware updates and maintaining the charger itself. And that's a required module for the OSPP module. And then the OSPP module can be linked up to the authentication module to make the authentication work. And now you have a charger that is remote manageable, and it can authorize via RFID. And maybe you want to add some additional stuff. You want to add a local API that can talk to a local energy management system, for example. You can add in the API module that gives a local API to manage the charging station locally. So it's just drag and drop UI to build a charger. Yeah, you can have a DC charger, you can have AC chargers depending on what you need, but this is really the way you can set up your first charger. Nowadays, last year this was like our main feature. Nowadays we see more and more people just taking because this generates a JSON file that is used by the code. Nowadays we hear a lot more that people are just adding the JSON files or taking example JSON files and working in the JSON files directly. But it's a bit more error prone. So if somebody has a JSON file which doesn't work, we typically tell them, hey, load this into the UI and see what the UI makes out of this. And then typically they see that some modules are missing because they were misconfigured. EVerest can also be used as a simulator. You can run it as software or hardware in the loop for the protocols for vehicle test communication. But you can also use it for OSPP or the other protocols. We see a lot of charge point operators nowadays that are developed. So a lot of those charge point operators that are managing charging stations have developed their own software. I've worked for a lot of those companies, and what we typically would do is build a rudimentary charging station simulator to test our own development. Now we see more and more companies also using EVerest as their simulation tool. So if you would be working for a CPO and you need something to simulate a charging station, with EVerest you can just spin up a Docker container and have a full charging station with the correct state machines, with the correct functionality, and you don't need to maintain it anymore. It supports OSPP, it supports all the different protocols. So you can test everything that EVerest can do without having to write any code for yourself as a simulator. So current status of EVerest itself. Yeah, OSPP 1.6, so the main protocol now worldwide for managing charging stations is implemented. 2.0.1, core functionality is in. Yeah, we need to do a lot of additional features. That's ongoing work. There's a new version of this protocol coming out later this year, OSPP 2.1. This is also what will bring bidirectional charging functionality to chargers. Work is planned to start soon. It's an open source project, so it really depends a bit on who starts doing what and when. So the high level communication with 15.11.8, so the newer protocol to do charging. -2 was the version that's out for 10 years. That's fully implemented. -20 works. The happy part's working. A lot of the optional features haven't been implemented. We're now more and more debugging to make it more reliable. We have support for both AC and DC charging. We do DIN-spec, which is the older version for DC charging in Europe and also US and Australia. We are talking to the CHAdeMO organization to be allowed to do a open source implementation of CHAdeMO in Japan. We have a university in Malaysia that has an open source version or they have a version that isn't open source because that is officially not allowed by CHAdeMO. We're now working with all of us to try to make that part of Everest as well. And then we're also now talking to GPT, to the Chinese organization, to also do an open source implementation of GPT. So it looks like we're probably going to get all the protocols within Everest within hopefully this year already. So that looks really promising. Yeah, we do the AC protocols 61851 for Europe, and I think also Australia and Asia. And the US has a small variance on that, the SIE version. Modbus is implemented to talk to batteries, to talk to smart meters. And we are going to add more and more protocols, especially for home energy management systems. There's a lot of discussions to add protocols for that. And yeah, already mentioned, we have a lot of bindings for languages in Everest. Yeah, if you want to build your own charger, or if you want to do a commercial project and you want to work with Everest, we created open hardware. Yeah, we needed hardware to develop a charger on. You can't just buy a charger and put your own software on it. It should be secure enough that you can't just install any firmware. So we built our own open hardware as a software development kit. We release that as open hardware even, so you can download all the files that you need to build your own boards. Runs a Raspberry Pi compute module. It contains a power board for AC charging, and it controls the high-level communication for that is needed to control the power board. It's a bit over-engineered. It's really developed as a software development kit, so if you want to build any kind of charger, we try to put as much on there as possible. It contains a GPS chip. If you build a full module, it even has a full color touchscreen display. For an AC wall box, that's a bit overkill, but if you want to do an AC public charger and you want to do something with the graphical user interface, we thought it's useful to have a good color display on the development kit. We do sell them. We make them in small batches. You can buy them from us. Or if you have the equipment available, you can build yourself. Also, the files for the housing are available as open hardware, so you can do all of this yourself. There is even more coming. There's a Chinese company called Seed. They do a lot of DIY hardware and development kits for the hackers out there that are developing their own stuff for home use. And they did a Everest charger already as a demo, and they're also working on a development, an Everest-based AC charger board themselves. So there's more and more coming of hardware to play around at home if you want to build an AC charger. If you do it, please be a bit careful with it. You're still playing around with a lot of power. So know what you're doing when you're playing around with electricity when you start building something like this. If you want to get involved with Everest, code is of course on GitHub. The hardware design and the microcontroller firmware that you would need for the open hardware is in the Pionix public repositories. Everest mailing list, our project based on the Linux Foundation. We have a quick start guide so we quite good documentation on how to get started. We have a technical steering committee call every fourth Thursday of the month. You can join. So if you join the mailing list, you will get the announcements of when those calls are. We started using an open source chat tool as well. We first wanted to do Slack, and then somebody said, yeah, we're open source, why not do Zulip? So we're on Zulip. That's where all the developers are quickly reachable. They respond to questions, but also discuss current development. We have a lot of different weekly calls. We have 5 working groups nowadays. I think if you want to join, the main call to join is the general and Q&A call on Tuesdays. Also, all these calls will be announced on the mailing list. So yeah, hope to see new people join the community. Any questions?
Thank you very much, Robert, for your talk. Do we have any questions?
Thank you for the talk. I'm curious if this suite of protocols gets used on larger devices like buses and electric trains and things like that, like transport that scales, not individual transport that doesn't scale.
Yeah. Trains, the ones with overhead lines, not, because they don't charge. I'm not sure what they will do with, because I've seen this prototype of trains that can also charge. There is this new protocol coming out, which is called MCS, Megawatt Charging System. This is basically 15.8, just with a different connector, and it's now a lot bigger. I've had it in my hands. That beast can do up to 3.7 megawatt, so that's huge. And this is for heavy duty equipment, so mining equipment, construction vehicles, trucks. The protocol is basically the same. There might be some additional stuff. The biggest change there for us will be the communication layer. So 15.8 currently uses power line communication. So it's the same chip that was made to do power line Ethernet over power line at home. That is used for communication between the vehicle and the charger. With MCS, that is replaced by a single wire Ethernet. So with a bit more speed and a bit more reliable connection, hopefully. With buses, you see a lot of pantograph chargers. And we're really proud of that. One of the guys that is working on that protocol for the pantograph chargers is actively working with us. So he wrote the spec and is now actively implementing that 15.8-8 into Everest. So we talked to the guy that has wrote the spec like every week, and he's actively working on getting that into Everest as well. So yeah, we're convinced we will be also supporting the heavy equipment very soon.
Well, there's a lot of different questions I'd love to ask, but I think the one that is most sort of important in my head is it's great to see an open source project coming in a landscape that is essentially threatened by monopoly power. And I'm wondering if the largest charger or installer of chargers in the world, which is Tesla, is working with you, and what's your relationship with them so far?
The main relationship I have with Tesla is that within the standardization bodies where OCPI and OSFP is being developed, Tesla is also active. So where Tesla started out doing everything themselves, they've opened up for roaming as well. So in Europe, there's already a couple of companies that have roaming with Tesla. So Tesla is now providing OCPI to some companies where you can use a different app to charge your non-Tesla vehicle on a Tesla charging station. And they're also active in the working groups for OSPP nowadays. So yeah, and they're focusing a lot on, I'm vice chair of a new working group called OSPP Lite. And the Tesla guys are quite active to make the OSPP protocol a bit more light, probably to make it work on their destination charges, but I'm not telling that much about it.
Yeah, thank you for your talk. Are there any, what's the Australian situation in the project? Have you got any comments on that?
We are talking to 2 companies in Australia. Both are NDA, so can't mention them, but we're talking to 2 companies in Australia that are looking into implementing Everest in their chargers. One is a new startup. So for them, it's blank field, so it's easy to go open source. The other one already has chargers out in the field. Then it's a bit more work to what do you do with the existing infrastructure. You're not going to replace your existing software on existing infrastructure with open source software, unless your software is really bad, maybe, but it will cost money to replace existing software. So typically, this discussion will probably become more active when they go for a new generation of product, where they're going to redesign their hardware, rethink their strategy also for software. And that's typically the point where, at least that's a discussion that we've seen with others as well, is that's where they're open to look into a different software stack and typically open source. But yeah, sorry, I can't mention names at the moment.
Do we have any further questions? Well, thank you very much for your talk, Robert.
Hey, thanks for your attention. and have a nice day.